Any student, Basil, Janita, Abdullah, you are giving exam in a few days. Can you answer this question, please? Ji beta, I'm waiting for an answer. Come on. Abdullah, are you here, beta?
Sir, I think your mic is mute.
Oh, I'm so sorry. Yes, my mic is mute. I'm so sorry. I was asking questions again and again. I'm so sorry. My mic was muted. Abdullah, can you answer? Thank you, Abdullah. I was actually shouting Abdullah, Abdullah again and again. Thank you, Abdullah. Can you please tell what's the answer to this question? Yes, please. I'm waiting.
Sir, since the power is constant, increasing the voltage will decrease the current. Uh, Current is the main source of producing thermal energy in the wires, which leads to losses. That is why transmission with a higher voltage leads to lesser current and more efficiency.
Brilliant. Excellent. So basically, the power in transmission must remain constant. Okay. Um, Power is the product of current and voltage. Higher voltages, higher voltages mean lower currents, and currents being lower cause lesser losses. This ensures efficient transmission by lowering the current through higher voltages. Ishal, Janita, Beta Muazzam, Basil, please tell me if you have understood this question.
Yes, sir.
Do you see how important these questions are? And I've been repeating them again and again in my lecture as well, I guess. Okay, now this question. This question we did as well. Let's go to the next question here. Can you, Beta Janita, read this question for everybody, please? And then let's explain.
A transformer consists of a primary coil and a secondary coil on an iron core. An alternating voltage is connected to the primary coil. Describe and explain the operation of the transformer.
Yes. So you have to describe and explain the operation of a transformer. Now you don't have to give a reason. Describe means you have to only describe, but you have to describe everything. So can you please describe, Muazzam?
Yes, sir. The current flows through the primary coil, which causes the change in current causes a magnetic flux, which results in a current in this, which results in a change in the EMF in the secondary coil, which leads to a current and this.
Well done. Changing alternating current in primary, which is the input, okay, produces the changing magnetic field in which passes through the iron core, okay. um, this changing magnetic field um, through the secondary coil, which is basically the output, induces an EMF in the secondary coil. Yes, this is how a transformer basically works. Ishal Umar Chaudhary, did you understand? I am waiting for a reply. Okay, Basil, Mozam, did you understand?
Yes, sir.
Ishal,
Yes,
you're not
sir.
replying, beta. Okay, so Asmat, any questions so far? Okay, then he is replying in the chat box. Okay, moving ahead now. So this question is probably clear to all. No questions. This is also something we have done in the worksheet, I guess. So let's move to the next question of a DC motor. Here we go. You have to label these parts. Can someone label part A and then label part B as well, please?
Is part A carbon carbon fibers?
Part A is what? Carbon brushes.
Yes, carbon
Well done.
brushes.
What about part B, Basil?
Slip rings.
No, these are split rings because
Slip.
this is a motor.
Oh, okay.
The slip rings are in case of a generator.
Generate. Okay.
Does that make sense?
Yes.
Okay, then. This is clear fully. So, part 2. Can you read part 2, Basil? Beta?
Okay. On Fig 9.2, write in each of the boxes the name of the part of the motor to
No,
which
no,
the
no.
arrow is pointing.
This is we
Oh,
already
okay.
the part 2 I am.
Second part. Okay. State which way the coil of the motor will rotate when the switch is closed when viewed from the position X.
Okay, when viewed from position X, you have to tell. Okay, from here you are viewing Janita, Basil, Muazzam, Abdullah. You are viewing from here. Okay, you are seeing from here. So will it rotate
Okay.
in this direction or will it rotate in this direction? Is the question they have asked. First of all, how do we tell which direction does it rotate in?
The Fleming's laws.
The Fleming's law.
Hmm?
Sir, the Fleming's left-hand rule.
Fleming's left hand. In motor, we always use the Fleming's left hand rule. Well done. And applying Fleming's left hand rule to this, you guys will be telling me whether it moves in the direction of the blue arrow or in the direction of the red arrow. Apply the
Um,
left hand rule. I'm also applying force field.
okay.
And you have to look at the direction of the current through the battery that's going as well. That's positive to negative. Force field current. Current is going this. Okay, current, and then field is this. So I found the direction. Did you? Is it going to rotate in the direction of the blue arrow, or will it rotate in the direction of?
Sir, the
Blues.
blue arrow.
Sorry,
Sir, the blue
blue arrow. It will rotate in the direction of the blue arrow just clockwise, and the reason for that is going to be this way, because listen very carefully if someone cannot figure out. So it is passing through the positive here like this. So the current, which is the middle finger, points in the direction which is going to be of the blue arrow. Okay, and the field is from north to south. So what happens is, basically using the left hand rule, you will first have to keep it like this. So current is in the arrow of the blue one. The field has to be arranged keeping current the same like this. So this side, the thumb shows that it's going down. So this side going down means it rotates in the clockwise direction as seen from X. I've shared the same thing that I'm explaining in the form of a video on your WhatsApp as well. It is loading. So everybody watch that as well, in order to ensure that you know how to apply Fleming's left hand rule for knowing which direction this coil will be rotating. I am waiting. Yes, did you understand? Did you get it? Shall I move ahead?
yes, sir.
Yes, sir.
Okay then.